Hello, hi everyone. So we are going to talk about probability and night Bayes as an algorithm over here. So I'll probably start with basics of probabilities. Most of you would already know it, but so that you get a refresher, we'll go ahead. Okay. Let's say I'm tossing a coin. So what will be the probability of getting a head, assuming the coin is fair, right? So probability is nothing but the ratio of favorable events and divided by total number of events, right? So in this case, the favorable event is 1 when I get ahead, and total number of possible events are 2. So my probability becomes half, 0.5. Right? Similarly, let's say I have a fair coin and I have a dice, right? So both of these are fair. So what is the probability that I'll get a head on coin and I'll get a number 6, for example, on my dice? So because these two are mutually exclusive events, right? So I can write it in this way: probability of getting a head multiplied by probability of getting a 6. Probability of getting head, as we saw in previous example, is 1 by 2. Following the same logic, the favorable condition is 1, and the total number of possible outcomes is 6, right? So my probability of getting a head as well as getting number 6 on dice becomes 1 by 2, right? So this is the basic of probability. So let's say I have one data set. Okay, let's say this is a database I have. So this shows whether a particular individual has visited any foreign country, yes or no, and they were diagnosed with corona or not. Okay, so if I want to know what is the probability of someone getting diagnosed with corona if they have visited, right? So this is known as conditional probability, and I can write it in a way that diagnosing with corona given they have visited, right? So this is nothing but known as conditional probability, right? So in this example, so first we need to filter out what are the cases where someone has visited foreign country. So there are the 4 cases where someone has visited foreign country, and if I need to calculate this, so the events which I'm interested in are these 3. These are the favorable events. So this is 3 divided by total number of events. This is 4. This comes out to be 0.75. Okay, so 0.75 is the probability that someone will get diagnosed with corona given they have visited any foreign country. Okay, now let's see one more example. Let's see one more example that I'm interested to know what is the probability of someone getting liver disease given they are alcoholic. Okay, so this is the quantity I'm interested in, but the probabilities which I have with me are, let's say I have one probability A, which is whether out of the total patients who have visited my clinic, how many of them have a liver disease. Okay, so let's denote it with P of A. Let's say out of all the people, 10% have liver disease. So my probability becomes 0.1. Okay, so the other number which I have is out of total patients who have visited my clinic, how many are alcoholic? So say out of total patients who have visited my clinic, I saw that 5% of them are alcoholic, so my probability become 0.05. Okay. Now I have third quantity, which is out of total guys who had liver disease, how many of them were alcoholic? I can write alcoholic given they had liver disease. Okay, so this is, let's say, 7% or 0.07. Okay, now I'm interested in this quantity, but I directly don't have these numbers with me. I individually have whether a patient has liver disease, whether customer was alcoholic, or what is the probability of someone being alcoholic given they had liver disease. But I am interested in this particular probability which I don't have directly. Okay. So what Bayesian theorem says is, or Bayes theorem says is that the conditional probabilities can be reversed. So when I say reverse, it's basically, let's say I'm interested in P A given P. If I don't have it, I can reduce it from this particular relationship. Right? So this relationship is known as Bayes theorem. Okay, so if I fill in numbers over here from this example, so I'm interested in probability of someone having liver disease given they're alcoholic. So I can write it someone having liver disease and being alcoholic. Then I can write what is the probability of having liver disease, what is the probability of having alcoholism habit. Okay, putting these numbers, I can get 0.07. Then having liver disease is nothing but 0.1. Then probability of being alcoholic 0.05. This comes out to be 0.14. So this becomes my probability of someone having liver disease given they are alcoholic. Okay, so this is the way we use Bayes theorem. Now we'll see how can we use this particular framework for our machine learning problems. Let's say I have this data which I have collected from previous football matches, which is basically given the outlook, given the temperature, given the humidity and wind speed, whether a football match was played or not. So this is the data I have. This is also known as the prior information which I have. Okay, so let's say I am interested in to know whether a game will be played or not. Given outlook is sunny, okay, and temperature is cold, humidity is high, and wind is, let's say, strong. Okay, so given these weather conditions, can I predict whether a football match will be played or not? Okay, so right now I don't see any particular combination which directly follows this. I don't see sunny, cold, high, and strong coming together. So let's denote this as weather. So the probability which we are interested in is whether a match will be played or not given the weather conditions. Okay, so for getting this from Bayes theorem, I can write that what was the probability of this weather given match was played, what was the probability of match played overall, and what is the probability of this weather. Okay. So this is the objective which we want to achieve. Let's take a step back. Okay. So let's create one table and follow me here. Let's say I'm interested in this variable outlook over here. So I have outlook as sunny, I have outlook as overcast, and I'll have rainy. Then matches whether they were played or not. Then I want to know what is the probability of games being played. What is the probability of games not being played? Okay. So for this first combination, we need to see those observations where outlook was sunny and game was played. So not this one over here, and this one over here, right? So I have two instances where outlook was sunny and game was played. Similarly, I have the remaining three observations where outlook was sunny and game was not played. Okay. Similarly, for outlook, I can write 4 0 given the same logic. Okay. So there are total 5 instances where game was not played, and there are total 9 instances where game was played. Now, in this entity over here, we want to calculate the probability of weather being sunny given the match was played. Okay, so these are the favorable events where game was played and it was sunny, and my total number of events are 9. So this is the probability of for this example outlook being sunny given game was played. Okay. Similarly, I can write for all. Right. So this is the combination for all the possible scenarios for outlook variable. Similarly, we can create for all other variables as well. Okay. Now let's get back to our example over here. So first thing is we want to calculate the probability of weather. So probability of weather, because these all are exclusive events, that's the assumption. We can simply do multiplication of all. Right. So probability of sunny is nothing but how many times it was sunny. So out of total 14 times, I have 9 by 14. Similarly, probability of cold, we can see there are 3, 4 instances. So let's go back here. So I can write it as 4 by 14. Similarly, for high humidity, I have 1, 2, 3, 4, 5, 6, and 7 instances. And for strong wind, I have 1, 2, 3, 4, 5, and 6 of them over here. Okay. So by doing all the multiplication, this will come out to be 0.02186. Okay. So I hope it's clear. Let's remove all this calculation. So we have calculated our first value over here. Probability of match being played, you would have directly guessed, is 9 by 14, because out of 14 instances, there are total 9 instances where the game was played. Okay. Now let's see how can we calculate this third quantity, which is probability of whether given match was played. Okay. So this kind of table which we created for Outlook will help me out here. So from here I see that this is the probability of Outlook being sunny when game was played. Okay, so this will be 2 by 9, right? Similarly, I'll get probability of temperature being cold given the match was played as 3 by 9. Similarly, temp humidity being high given the match was played, I will have again 3 by 9. Similarly, for wind being strong and the game was played, let's see this and calculate it so that you understand. So there are 1, 2, 3, 4, 5, 6, 7, 8, and 9 instances where game was played. Out of that, if I see where wind was strong, so this is one instance, this is one instance, this is one instance. So in total, I will have 3 by 9 is the probability over here. Okay. Now, what I can essentially do is I can put all these numbers over here. So this right. So what I can do is I can essentially put all these numbers over here, and the probability of match being played given the weather condition, we will get it as 0.2429. Okay. Now, so this is the probability of match being played. Now, similarly, we'll have to calculate what is the probability of match not being played given the weather conditions. So my top formula remains the same. So the overall Bayesian formula remains the same. The probability of wind remains the same. Now, as we are talking about match not being played, I'll have 5 by 14 over here, and this was for match being played. You can see 9 over here. Similarly, for match being not played, I will have 3 by 5. You see from here, right? So what is the probability of Outlook being sunny when game was not played? 3 by 5. Similarly, for others, I can calculate. Let's again see the fourth one where wind was strong and the game was not played. Now I have this particular case over here. This case is 4 and 5. Out of that, we see that uh, this is one observation where wind was strong. This is one observation where wind was strong, and this is the last observation. Right? So I'll have probability of 3 by 5. Now again, inputting all these three values into the top formula, we'll get probability of as 0.94. from here we can see that match being not played has higher probability given the weather condition compared to match being played. Thank you. That's it for night based intuition.